So the next thing we're going to talk about is the period of a sine and cosine function. And the period is from the distance from one point to a repeating y value. And so when it repeats itself, that's known as the period. Okay? The way we figure out period is by using this equation right here. 2 pi divided by the absolute value of b. The reason we use absolute value because it does not matter if it's positive or negative. We still just take 2 pi divided by that value, positive or negative, and we find out what our period is. So the reason, or the place where b is found, is right here. It's the number in front of the x value in our sine and cosine function. So it says, describe how the graphs of f of x is cosine of x and g of x cosine of x divided by 3 are related. Then find the period of g of x and sketch at least one period of both functions on the same coordinate axes. So f of x is the cosine of x. Okay? So x and y values, we put in the same values of x, 0, pi over 2, pi, 3 pi over 2, and 2 pi. That's one period. And so when we put 0 in, we get 1. Pi over 2 is 0. Pi is negative 1. 3 pi over 2 is 0. And 2 pi is 1. Now if I'm looking at g of x, which is the cosine of x over 3, if I make my table, first I'm going to look at my period. So we said that the period is 2 pi divided by the absolute value of the number in front of x. Now x divided by 3 is the same as 1/3 of x. So the absolute value of 1/3 right there. So if you were to simplify this, my period then is 6 pi. So instead of going from 0 to 2 pi in a period, I'm going to go from 0 to 6 pi. So to figure out my values in my table, I'm going to start with 0, and I want to end at 6 pi. So just like I had 5 points before, let's have 5 points here. So right in between 0 and 6 pi is going to be 3 pi. And then I find the midpoint between 0 and 3 pi is going to be 3 pi over 2. And the midpoint between 3 pi and 6 pi is going to be 9 pi over 2. And if you're unsure of how I got that, refresh yourself on how to find the midpoint between two things. Add the values divided by 2. So I put in my values of x into cosine x divided by 3. And again, I'm going to get the same values. I'm going to get 1, 0, negative 1, 0, 1. And now you're probably confused at why I get the same values. Well, the reason I get the same values for y is because I changed what I put in for x. I changed my values. So let's graph this and see what we get. Now my y values stay between 1, 0, and negative 1. But what changes is my x values. So I start at 0, pi over 2, pi, 3 pi over 2, 2 pi. Then I would get 5 pi over 2, 3 pi, 7 pi over 2, 4 pi, 9 pi over 2, 5 pi, 11 pi over 2, 6 pi. Okay, so those are my values. And now that's going to make one period of my g of x. Okay, so my f of x, I'm going to do in black. Actually, I'll choose to do it in purple. Okay, f of x. So that was a normal cosine graph. So 0, 1, 0, 1/2, negative 1, 0, 1, and I'll just keep going. You'll see that the period is the same, so it's just going to repeat itself every time. And so just like before, okay, there's my cosine of x. Now this one's actually 3 periods, okay, because you'll see from here to here is 1, there to the next is 2, 3 periods from 0 to 6 pi. Now, I'll take my g of x. Now that one, 0 is still 1, but now my next 0 was 3 pi over 2. My negative 1 was at 3 pi. My next 0 was at 9 pi over 2. And then my final 1 was at 6 pi. So now if I connect these dots, okay, you'll see that it starts at 1, ends at 1, but that's only 1 period. So how are they related? They're related because they both make 1, or g of x makes 1 period from 0 to 6 pi, but the other one makes 3 periods from 0 to 6 pi. Here's some more examples if you'd like to look at their similarities and differences. So the next thing we're going to talk about then is frequency. Now the way we find frequency is similar to how we find period. It's actually 1 divided by the period. So in the last one, when we had for cosine of x over 3, we said our period was 6 pi. So our frequency then would be 1 over 6 pi. That would be our frequency. So you might ask, what exactly is frequency? It's the number of cycles the function completes in 1 unit interval. So essentially, it's the number of times you have your graph complete a cycle. So here's a real-world example to find frequency. It says musical notes are classified by frequency. In the equal tempered scale, middle C has a frequency of 262 hertz. Use this information to write an equation for a sine function that can be used to model the initial behavior of the sound wave associated with middle C having an amplitude of 0.2. So we're asked to find a sine function for middle C. So we have to think about our sine functions. To this point, we know A, the number in front of our sine function is the amplitude, and our B, the value in front of x in our sine function, is the period. So, amplitude, period. Now they don't tell us what the period is, instead they tell us what the frequency is. So the frequency is 262. So if you think back to what frequency was, it was 1 over the period. So if that's the case, then that means that if 1 over the period is 262, the period then is going to be 1 over 262. Now an easy way to do that if you're interested is like basically a cross multiplication problem. Period times 262 is equal to 1 times 1, divide by 262, and this right here is going to be our period. Now we think to what the equation for period was. Remember, period was 2 pi over the absolute value of b. Well, we know that our absolute value of b is 1 over 262. So 2 pi over absolute value of 1, 262. Simplifying, remember when you're dividing by a fraction, you multiply by the reciprocal, you end up getting 524 pi. So that is my period. Next, I know that my amplitude, they already told me in my problem, my amplitude is 0.02. So finally, to write my equation of my sine function, it's going to be y equals 0.2, the amplitude, sine of 524 pi x. That right there is the equation of my middle C. Note,